Hello, welcome to ANS Solver. This is the second question of the paper. So I have written the question again for your reference, and this is 1 over 4 pi. Okay, just because it's cut out. So yeah, it's 1 over 4 pi. So now, looking at the question, I know this is a further integration question, and this is a concept called as bypaths. Okay, because two different variables are multiplied with each other and they belong to the isolate section of bypaths, where I means inverse, L means logs, A means algebra, T means trigonometry, and E means exponents. Okay, so now I can say x square is algebra and cos 2x is trigo. Algebra comes before trigo, so u is x square and v dash is cos 2x. Correct? This is how we do it. Now my u dash, which is a differentiation of x square, is 2x, and my v, which is the integration of cos 2x. The integration for cos is simple, it's sine, but it's sine 2x over the coefficient of x, which is 2. Now I use my formula, which is uv, with the limits ab minus the limits with vu dash. So u into v is simply x square into sine 2x over 2. So x square sine 2x over 2 with the limits 0 and 1 upon 4 pi minus 0 and 1 upon 4 pi with vu dash, which is simply 2x into sine 2x over 2 dx. So I can cancel the 2 here. So I get x square sine 2x over 2. Okay? Yeah. With 0 and 1 upon 4 pi minus the integration of 0 and 1 upon 4 pi with x sine 2x dx. Okay, so now what I can do is I can simply split this into two parts. So now here, first I'll put the upper limit in the place of x. So you can do that on the calc. First you can go for sine. Make sure you're on the radian mode. First you can do sine 2 into 1 over 4 pi. When you do that, you get your answer as 1. And 1 upon 4 pi, you know, is simply 1 over 16 pi square. Correct? Into 1 over 2. Correct? This is what I get. Minus, I know when I put 0, I'll get 0. So I can basically write this as pi square over 16 into 2, which is 32. Now, what I simply need to do is, if I see this part here, this is bypaths again, because if you see isolate, this belongs to algebra and this belongs to trigo. So we integrate this again by bypaths. So I take my u as x, I take my v dash as sine 2x. So I take my u dash as the differentiation of x, which is 1, and v as the integration of sine 2x. The integration for sine is minus cos 2x over the coefficient of x, which is 2. Now I can use the same formula, which is u into v, which I get minus cos 2x over 2 with the limit 0 and 1 upon 4 pi minus vu dash. It's simply because of the minus here and minus here, this can become plus cos 2x over 2 dx because u dash is 1. Now what I can simply do is I can split this into further parts. Now here in the place of x I can put 1 upon 4 pi. So just simply do cos into 2 into 1 over 4 pi on the calc C. So the value I get during that is 0. So I know this full thing is 0 minus, now when I put 0 in the place of x here, I know I'll get 0. So this full thing I get as 0. Now I need to integrate cos 2x over 2. So integration of cos is sine. So I can write this as sine 2x over the pre-existing 2 into the coefficient of x, which is 2. Okay, with obviously the limit 0 and 1 upon 4 pi. So this can be written as sine 2x over 4 with 0 and 1 upon 4 pi. So now what I can do is, in the place of x, I can first put 1 upon 4 pi. So on the calc C, just do sine 2 into 1 over 4 pi. When you do that, you get your answer as 1. So you get 1 over 4 minus, I know when you put 0 in the place of x, I get 0 because sine 0 is 0. So I get 1 upon 4 pi. Now, putting everything together, I have a pi square here. It's pi square over 32 minus, because of the minus here, okay, minus 1 over 4. So now what do I need to show? I need to show 1 over 32 pi square minus 8. So I can take 1 over 32 common. So I have pi square here as it is, minus, if I take 8 here, okay, I know when I expand this, I'll get this value again, correct? Because 8 over 32 is 1 over 4. So I can simply expand it and write it like this. 1 over 32 with pi minus 8, which is the final answer of the question. You can just expand and see, you'll get this answer again. So yeah, this is pi square, just in case. Yeah.